Thanks everyone for joining us today. I will be talking with NeXTimber about CLT and glue-laminated timber. But before we get started, Ben, did you want to do an acknowledgement?
Do an acknowledgement of country before we get started. So Christina and I, we pay respects to the Kaurna people on which lands we meet, and we like to pay our respects to elders past and present and emerging.
Thanks, Ben. And I'll just introduce our presenter today, who is Jeremy Church. He's the General Manager of Sales and Technical at NeXTimber by Timberlink, where he oversees the technical development of NeXTimber's cross-laminated timber and glue-laminated timber products. With over 15 years experience as a practicing structural engineer, Jeremy has been actively involved in various capacities within the timber industry since 2017. His understanding of structural mechanics and material performance has been instrumental in advancing innovative design solutions in timber construction. Jeremy is a proactive member of industry initiatives, including Timber Technical Advisory Group and Australian Timber Construction Education Network. He also serves as a board member of the Engineered Wood Products Association of Australia, where he continues to advocate for sustainable practices and technological advancements in engineered wood products. So, hi, Jeremy.
Thanks. I'm well, thank you. Thanks very much for having me. From myself and Jackie, my colleague, and the wider Timberlink community. Thanks for having us along.
No, thanks for coming in. We appreciate it.
So I'll just give you an introduction on who Timberlink are. So before we go too much further, I'll just give you a bit of a snapshot of where we are as a industry, I suppose, globally. So over the last 5 years, we've seen mass timber. When we talk about mass timber, we're talking about cross-laminated timber, glue-laminated timber. In European and US markets, we've actually seen the consumption or the uptake of mass timber increase by about 15 to 20% year on year for the past 5 years in both the European and US market. We're expecting the US market to double again in the next 5 years. So the actual overall consumption of mass timber in that market is expected to really kick. And we're hoping to see sort of similar trends like that follow into Australia, with us being sort of the second main manufacturer on the Australian mainland. So as Timberlink is an industry, so we're a softwood producer, softwood manufacturer. We're probably the second largest softwood producer in Australia at the moment. We have 2 sawmills, one in just out in South Australia, just out of Mount Gambier in a little township called Tarpeena, and another one down in Bell Bay, which is just out of Launceston in Tasmania. There are 2 manufacturing facilities. Our head office is in Melbourne. That's where I'm coming in from today. And then we have distribution centres all across the southern seaboard of Australia, as well as some in New Zealand too. Our main product categories that we produce to date have really been focused on the sawn softwood sector, which really supplies into the housing market. We sell treated product, untreated product, but really what you'd see sort of in framing and frame and truss. And about 5 years ago, the business went on a journey to look at what the next step sort of evolution of product categories would be to sort of support that sector, as well as diversifying our portfolio to look at other sectors. And that's where the brainchild for mass timber came aboard. There was already one existing manufacturer in Australia, being XLAM. We're sort of the second mover. And so we decided to go on that journey about 5 years ago. So it's been about 5 years to get to this point. A lot of planning. We've had to build a facility. And we're actively in the market and been there for about a year already. So the way that our business is actually structured, so Timberlink actually sits inside a portfolio of New Forest. So New Forest is a forestry company, a superannuation fund, and they manage about $10 billion worth of assets globally. And those assets are predominantly forestry assets. So we sit inside one of their portfolio funds, and that gives us access to the fibre that we can then use in our product. We don't get all of our fibre for our products from New Forest, but we get a fair portion of it, and we get it from other suppliers too. But we sit within that portfolio. So we're trying to return funds back to those investors. And the NeXTimber as a brand category sits underneath Timberlink. So it still sits within the same organisation, same reporting structure, but there's just that supply chain from seed to structure. You get that through NeXTimber. So the sawmill where where NeXTimber is located is, as I mentioned, just outside of Mount Gambier in a little township called Tarpina. That's very close to the forest. So the forest is actually literally on our doorstep. And we actually grow the seedlings in the nursery in that region, and then they get taken out into the forest and they plant and they stay there for about 28 years before they get harvested. Then they get harvested into sawn log, and some of that sawn log goes into the framing market, and some of it goes into our energy and wood products. So this is a snapshot of where the actual sawmill is, just out of Mount Gambier, and you can see how close the forest is to the sawmill. So we're literally right amongst it. So we got really good access to fibre. And the shed down the bottom left-hand corner of that image there, that's actually the NG Wood Products plant. So that came online last year, and we've been delivering projects ever since. So the two main product categories that we produce in that plant there are cross-laminated timber, and we can make panels which are 16 metres long, 3.5 metres wide, and actually up to 400 millimetres in thickness. And then the other product we sell to is glue-laminated timber. So if I go back to cross-laminated timber, that's what you'd make for panelized products. So walls, floors, roofs, any sort of horizontal spanning element or a big panelized element, you'd make that using cross-laminated timber. And then the other product we make is glue-laminated timber. So we can make those elements 12 metres long, 1 metre deep, and really up to 140 millimetres in width. And that's what you typically use to do beams, columns, and really discrete sort of structural elements. We all use softwood pine here. We don't use any hardwoods or anything like that. It's all radiata pine. And in addition to that, we really offer it on a service model basis. So we supply all the fixings and bracketry and components and membranes and anything else that sort of needs to go along to provide an ultimate solution to the end user. So the supply model that we operate under is fairly typical of what other timber manufacturers operate under. So we offer market support. So we don't do engineering design, we don't do architectural design, but we'll actually go ahead and support designers to be able to do their design. So they'll be providing technical literature, technical guidance, support, documents, any sort of other thing that's required. Once that design is complete and we've actually tendered for the job and we've secured the job, we have a team here of draftsmen that actually do the modeling. So we'll do a full virtual model down to the millimeter. And that's what we actually model is what we actually manufacture. So we go through a very rigorous approval process with the whole design team to make sure that it's all fully coordinated before we actually go to manufacture. Then we manufacture it, and we also manage the freight and logistics. So when we deliver things to site, we want to make sure they're going to be arriving in the sequence they're going to be installed. And so we'll break it down into several different truckloads with all the panels and components on each individual truckload. So it's a very process-driven process, and it requires a lot of input from all the stakeholders along this supply chain to get a successful outcome. So a really high level of engagement and coordination happens through this process. So in terms of the technology that we use within our plant, we use what we call a radio frequency press, which is, in really crude terms, is kind of like an oversized microwave. So the adhesive we use is a melamine adhesive, and that requires energy and heat to actually activate. Now, one of the key reasons as to why we use that glue is because of its superior heat resistant performance. So when you're going into commercial buildings, you're going to need to have a fire resistance level on those buildings. And what our heat doesn't do is our glue doesn't degrade at temperature. So when you're designing for fire load, when the fire gets to a glue line, that glue line doesn't disintegrate and fall apart like some of the other glues that are out on the market. So it's a very robust adhesive. So we use a lot of technology in our plant. So as I mentioned before, we do the full model, we do the coordination. So we'll take the architectural inputs, the engineering inputs, the all design, we'll build a complete model. We can actually build some of that from Revit. So we actually take a Revit model and convert that typically in IFC or SAT format. Then we'll actually break it down into components. So what we call panelize it, break it down into components. Then we send that to a simulation process where we actually assign all the tools that are going to do the work. And then once we've done all that, then we actually send it to the machines and we actually start to actually process and manufacture the components. And then we follow a QA process after that. So with regards to testing and documentation, like as I mentioned before, the reason that we have the equipment that we have is really to do with the glue technology that we use. And all of our fire performance is supported by testing data and testing literature and certificates. So before we even started on this journey at NeXTimber, we'd had products made overseas using the adhesive that we're going to use with actual fibre from our plant. Set that over to some competitors in Germany. They made those products for us, brought them back here. And then we actually tested those and got 5 performance levels out of that. And without boring you too much on the detail, as I mentioned before, we don't get sort of what we call heat-induced delamination, which some other products get, which means we get a very consistent char rate and a very predictable char rate. So what an engineer essentially does is they'll determine how much fiber they're going to lose, and then they make sure at the end of that FRL period, they've still got enough structural integrity left, or enough structural component left, that the actual building structure will still stand up at that FRL period. So we have the capability to give technical details for stuff that's wrapped in fire rated plasterboard or stuff that's exposed. So, which most of the buildings we're doing these days have expressed timber components. So that data becomes hugely critical. Okay, so that's all supported with testing certificates, like I said. We've got some very comprehensive design guides and 5 performance guides available for download for designers to go and access via our website. So by all means, register there and access them. All our certificates are there as well. We can go up to 3 hours fire rating. Typically, you wouldn't go beyond 2, but we do have test data all the way up to 3. And the other key element here with regards to these buildings here, because we're building in such a it's a lighter building component to what you're talking with typically concrete. We've done a lot of testing data with CSIRO, so all those tested solutions for particularly for residential applications are all available through design guides with the performance criteria in those guides as well. And once again, that's accessible via our website. So some recent projects we've delivered, as I said, we came online last year and we started delivering projects into the market at the start of this year. First project we entered with was a residential project up in Sydney. So with that, we supplied walls, floors, stairs, all the lifting solutions. The actual whole project was broken down. So this is a double-story house. It was in 3 truckloads. So it's 115 cubic meters. That was installed in about 4 days from start to finish. So it's a very quick process. It requires that whole planning piece at the start to make sure that gets 100% right. So you get so you're not causing unnecessary site delays. And then after that project, we actually sort of went into more of the commercial space. And this is probably more of our bread and butter sort of stuff. The real target audience that this product is really made for, which we're seeing a lot of projects like this coming to space. So once again, this is a commercial industrial building up in Sydney. There was actually 3 timber suppliers on this, so it doesn't necessarily have to be just one timber supplier. So we supplied all the cross-laminated timber, the glue-laminated timber for this one. All the internal stuff was supplied by Australian Sustainable Hardwood in Victoria, and the external glue lam, because of some durability requirements, was sourced through Hine out of Queensland. So the 3 timber suppliers all on this one project to get a really good outcome for the customer. So that was about 300 cubic meters worth of timber, so probably about 10 truckloads or so. You can see in this image here, there's some service penetrations in the walls there. So we had to coordinate that with the service contractor, build that into our model. We cut all those penetrations, and yeah, that's what the finished product looks like. In terms of what else we supplied to the projects, like we actually applied all the temporary membranes to it. So these are just temporary, so they're more for construction moisture. And you can actually see some moisture ponding on the top of that slab at the bottom there on the first level. So this contractor here had a very rigid or robust moisture management plan in place when they constructed this, which meant they actually didn't have to do a lot of rectifications or remedials after that to sort of re-beautify some of the timbers once it's been exposed to the elements. So and that's what the trend has sort of been that way of recent, that a more proactive approach is more valued, and contractors are certainly heading that way. Now, the next project we delivered to was this very complicated building up in Sydney as well. So we've seen a lot of projects go up in Sydney of late, and this is actually in Barangaroo, so right in the CBD of Sydney, right on the waterfront. And what it actually is it's a steel frame with this very complex geometry made of CLT sitting on top of it. So by all means, it's not a great example of what we'd consider designed for manufacturing and assembly friendly. Assembly wise, it was very friendly, but manufacturing wise, it was an absolute nightmare. So it was a good one to cut your teeth on. And so all the panels were all very unique. Every single panel was different. There was a lot of machining that went on board. We had to actually cut a lot of chases underneath to sort of intersect with the steel work. So that was challenging for the team. But when it went together, not one panel had to be modified on site. So, and we can just see the complexity of some of the steel work in this image here. it actually went together like clockwork. So once again, all that planning that went ahead is testament to how well it went together on site. So yeah, very, very interesting. I don't think we'd want to do these every day of the week. I don't think we made a cent on it, but I don't give it anyway. It's a testament. Probably couldn't have been built out of any other product, to be quite frank. And then this one here, which is actually Tonsley, which is actually Factory of the Future. So we just finished delivering this at the end of September. About 1,000 cubic meters of timber went into this from our part. There's probably another 600 or 800 of glue-lam that went in by Australian Sustainable Hardwoods. So this is an Adelaide project. It's a hybrid structure. When we say hybrid, it's using concrete shear walls for stability. It's got some steel in there. It's got some glue-lam in there. So it's got a whole host of different components in there. It's about 22, 23 truckloads for us to get this to site, or as once again all manufactured down in Tarpina. We actually delivered it to a separate facility before actually getting to the site. So it went via a storage shed. And once again, we applied moisture membranes to the roof panels, which, as I said, seems to be a bit of a trend as to what the contractor's like. So that's what you can sort of see from the outset. It's a double-story building, CLT floor, CLT roof. We only did the CLT. All the glue-lam was done by Australian Sustainable Hardwoods. We've been involved in this project for the best part of 2 years. So Sarah showed a lot of confidence in us. Sarah, the main contractor, confidence in us being just coming online, and we're able to deliver this as quite successfully. So the team itself very, very proud of the outcome of this project. So, and South Australia should be in general. Now, with regards to certification, all our products have EPDs attached to them. All our framing and our glue and our MGM wood products. We also have declare labels for our products, EWPAA certification, as well as all the fire assessments and reports that go with that as well. We do have both FFC and PEFC certified products. So if you need that for a Living Buildings Future Challenge, I've got the terminology wrong, but we can supply the certification to support your applications into those projects. But all our products as a standard come with FFC and PEFC certification. And then with regards to sustainability as well, like I know this is a sustainability forum. So Timberlink takes sustainability very seriously. Like we've obviously got a very good resource in timber, and the fact that it sequesters carbon is we don't rest on the laurels of that. It's we're always looking at better ways that we can reduce our carbon footprint as an organisation, and we've signed up to the science-based targets for the Paris Agreement. So we're the only timber manufacturer, certainly in Australia, maybe globally, that's actually committed to doing that. So it's something that we've got a whole team here that works on that tirelessly to reduce our carbon footprint as much as we possibly can. So that sort of concludes sort of a brief summary of sort of NeXTimber, Timberlink as an organisation. We've got a whole host of technical resources available on our website, which are just free to access, free to download. There's myself and another technical engineer here. So if anyone has any questions, by all means, feel free to reach out to myself or to Luca, and we'll assist where needed. But other than that, I'd like to thank you for the opportunity to give you a brief introduction.
Thanks so much, Jeremy. That was really good presentation, and I think you covered quite a lot in a pretty short time. I might just throw it out to the audience if they've got any questions. Otherwise, I've got a few up my sleeve. So in your presentation, you mentioned that you've got a variety of different processes, and one of the first ones was support, I guess, to the design team and to the client. I'm just wondering, how early can you provide support? Because the sooner you can kind of embed a CLT as a product that is going to be used in a project, the less likely it's going to be removed later down the track, or
correct, yeah.
You'll pass through fewer hurdles.
Yeah, so I've been involved in this segment for probably the best part of 10 years now as a designer originally, and then going on to various different manufacturers, and now find myself at Timberlink. The projects that I've seen most successful have the ones that have been had the earliest involvement from not only just the manufacturer, but all the other stakeholders as well. So we're quite often seeing, even at a very early concept stage, where there might be nothing more than a massing drawing and sort of and a site and a bit of a vague concept as what the actual client wants. They might have made their mind up, hey, I want to do a timber building, or I'm really interested in doing a timber building for various reasons. They can bring in probably one of the critical people you can really bring into the conversation is actually the installer more than anything. They can add so much value to the conversation around how you want to build it, where you want to start, where you want to set your cranes up, where your access points are. But then if you can bring the manufacturing on the journey, because all the manufacturers have different sort of capabilities. And there's some nuances and some subtleties around what different manufacturers can do, but you probably really want to break it down. Am I going offshore? Am I going to Europe? Or am I going local? Am I going to get it from one of the local manufacturers? Because the local manufacturers can add a whole host of additional value. We can supply bigger components, which means less crane lifts, less crane cycle times, which means faster installation, less fixings, and a whole host of other value things that are a little bit subtle to what the differences are. So my advice is it can never be too early, is probably what I'm sort of getting at. And as I said, with Tonsley Estate, like we've been involved in that project for well over 2 years, and there was nothing more than a scheme. And we actually worked through with the design team there on actually saying, okay, these are going to be optimal grids. This is going to get the least amount of components. This is going to be the fastest thing to install. And then we swung sort of Ash into the equation at the same time. So it was just around pulling together a team at the start of the project and working through that process. But yeah, earlier rather than later is my best advice.
Yeah, great.
Yeah, I just wanted to sort of circle back to that residential example you had.
Yep.
Was that you sort of had walls and floors as your product that you sort of installed there? Can you talk a little bit more about that? Are they more like a SIP type of panel, like structurally insulated panel, or are they just pure sort of CLT panels as well? Maybe just if you could more to that one.
So they're 100% solid timber panels.
Yep.
And so we make a CLT panel by every layer is alternating to the previous layer. So if it's a floor panel, your long fibers are going to go down first, and then your cross layers second, and then you alternate them as you go up. So every layer is alternating as you work up the panel, and then we end up with a solid timber panel. So that project, if I remember rightly, the walls are probably 90 millimeters thick of solid timber panels, and the floors would be probably around 150 to 200, depending on how far the spans are for that job. And that seems to be a fairly typical sort of makeup for that. One thing I excluded from this presentation, just for the brevity of time, was hybrid structures are becoming more and more common in terms of people building with lightweight timber frame walls, but then use CLT floors, mainly because walls become quite expensive. There's a lot of fiber in walls, and your best bang for buck is really a timber, like a prefabricated timber frame with a CLT floor. And we're sort of seeing that a lot of interest coming from that sort of multi-residential sector, which is traditionally concrete. How can we convert some of those that be concrete precast and post-tension floor plates? How can we convert them into CLT floors with lightweight timber frames? There's a bit of a project going on in the industry to sort of get that moving a little bit, but there's a bit of interest in that space.
Yep. Yeah, cool. I love also that builder that you showed who are doing the moisture management through construction and having some form of temporary like membrane in place. I suppose, can you probably talk a bit more to sort of moisture and mold and those types of considerations when building with sort of CLT?
Yep. Yeah, like any timber product is, in order to get mold, you need moisture, you need food source, which is going to be your fiber from your timber product. So if you can remove those things, then you're sort of going a fair way to removing the risk of mold and decay. So the key critical element to avoiding it in the first place is by keeping the moisture out is the best thing. So, and that goes for not only necessary during construction, it tends to be fine because it dries out during that process, but like you don't want it to be wet before you go and put on your final finishes and things like that. We're actually trapping moisture inside it. And then your building envelope becomes hugely critical as well. So having the right external buildup is important from a design consideration point of view. So membranes, your insulation layer on the outside of the product, so keep the element warm and dry as much as possible. But we are seeing from a contractor's point of view a more and more proactive approach to keeping moisture out during construction. So membranes, we do end grain sealers in our product in our factory. Europeans go to the nth degree. Sometimes they even build tents over their structures. So, but no, it's certainly a design consideration that really needs to be addressed.
Yeah, awesome. Thanks for talking to that, Jeremy. I appreciate it.
Not a
Les,
problem.
did you have a question?
Great presentation, Jeremy. Thank you. My first question was your FSC certification, and you've got that. That's the big tick. That's the big one.
Yep.
Well done. My question generally is related to where's all of the timber coming from right across, if you like, and also including your competitors. If your expected growth or your growth you're hoping for 50%, you mentioned, I suspect it'll be a lot higher than that. And we saw what happened, for example, in the COVID period, where just that little bit of government incentive on home renovation, that spike just meant that people were waiting months and months and months for timber from the market. So that kind of demonstrates just a little blip can cause the problem of where's it coming from. And obviously your competitors like Ash, for example, have had recent problems with the Vic forests, the native timber being locked up, and the pressure from Tasmania is likely to go down the same pathway. So who, in essence, I suppose, who's doing the calculation on where all of this timber is actually coming from?
Yeah, so it's an interesting question, and it's it's actually a question we get asked quite a lot. So I'll just reframe with regards to NeXTimber, so probably gives you an understanding of sort of the ethos behind why Timberlink went down this path to go this, because we know that there is well, I wouldn't say shortage, but there are demand peaks with framing during the housing cycle. When you cut a log, you get a whole bunch of odd lengths out of a log. Like a tree is a natural occurring thing, and so we can't actually dictate what we actually get out of the actual tree itself. So we can sell 6.0 meter length pieces of timber to the cows come home, and we can sell 2.7 meter long studs to the cows come home. Where the timber industry struggles is when there's some really odd lengths. So we may get a batch of 3.3 meter long lengths that's still good structural fiber, which the housing market typically there's not a huge appetite for that, because it creates a whole bunch of waste, and also any length under 2.7 becomes less valuable to the end user. So we can take those shorter lengths particularly, would otherwise struggle to find home for, which we'd typically have to downgrade for merge grade and sell to pellet manufacturers and things like that to make pallets out of. And particularly now that the hardwood sector's closed up in Victoria, then they're looking for other sources of fiber where they can get that product for. But we can take short lengths of timber and actually finger join them all together to make a longer piece of timber, which we can then put into these engineered wood products. So with NeXTimber, we're not typically taking from what we would sell into the normal domestic housing market. We're taking products which we really struggle to find a home for typically, and we can reallocate them into, or reuse them as a more value proposition than selling it as downgrade into the pellet sector. So that's the whole ethos around NeXTimber. I know that Xlam are a little bit different. They use a different fiber allocation, which they struggle to get rid of or struggle to find a home for in their products. But it's really about not selling something you can sell every day of the week. It's about trying to find a different home for products that you'd struggle otherwise for.
So Daniel's asking, how does the shop drawing process work with a traditional procurement method of construction? Do shop drawing reviews typically need to be completed by the architect prior to the builder starting on site in order to allow for the manufacturing and delivery times to given the special nature of the structure? And then he's got a follow-up question of, in the construction of mass timber portal, are there cost efficiencies in having more beams at closer spacings to the top where secondary roof members can be removed? Presumably the beams can be shallower.
I'll answer the first question. With regards to shop drawings, us and most timber manufacturers run a very rigorous approval process. So we run a 3-stage process here. So the first thing we do is we take the design from the architects and the engineers. We do a massing model, and we get all the geometry of the massing model approved, and that usually goes back and forth a couple of times, because there's usually a couple of questions around how does this detail work, or how does that connection work, or what's interfacing with what. And so we get the massing model approved. Once that's approved, then we actually bring that back and we actually break it up into individual components and individual panels. But then we get that approved. And then once that includes all the penetrations and holes and services and things that need to go into it. And then once that gets approved, we take the comments back, if there are any, and then do a final touch up. And then we send it off back again for a final sign off before it actually gets manufactured. So that whole process there, from where to go for say a residential home, it actually doesn't really matter if it's a residential home or a commercial building. It actually takes about the same, because it's the process is the same, but it can take anywhere between 6 and 12 weeks, depending on the scale of the project. Now, people go, "Oh, geez, that's a long time." Well, not really, because you do that while you're building your foundations, or you do it before you're building your foundations. And so we try to operate in a just-in-time manufacturing process where we do all the upfront work, and then we actually go into production and deliver a final solution to the site. So yeah, it's usually a 3-stage process, takes anywhere between 6 and 12 weeks, depending on how complex and complicated things are. Yeah, with regards to the design efficiencies, I'd probably suggest we have a look at that on a case-by-case basis. I don't want to make any generalizations. A CLT roof panel, like 90 millimeters thick, can comfortably span about 4 to 4.5 meters. Not a problem. So the thing you need to think about with secondary members as well, every secondary member has to be installed. So every beam has 2 ends, so it's got 2 connections. It has to be, each individual component has to be lifted, and then you've got a roof panel on top of that. So my prerogative typically when I try to design is how to design with the least number of components, but also being a little bit practical about it. It's about as close as I can get to an answer without actually seeing some drawings. But I try and think of what's the least number of crane operations I can use.
The questions. Thank you. Thanks a lot, Jeremy. I had 2 questions. So I'm actually coming from a landscape architectural perspective. That's my background. So my first question was, do you have any external applications for the products? I think I saw there was decking as a treated pine product that you may offer. Do you have any other applications?
Yeah, so typically in external, we wouldn't typically recommend that CLT, cross-laminated timber, gets used in an external application. It's not warranted for external above ground use. We can make it with a treatment. That's typically we're seeing that in the New Zealand market predominantly, because they've got their leaky house sort of conditions say that some products have to be treated. So we've got code mark for treated CLT, but that's for internal use of bathrooms, laundries, wet areas, places like that, but not for external above ground applications where it's going to be potentially saturated or wet for eternity. Glue-laminated timber is different. So glue-laminated timber, we supply that in H3 treated, so suitable for external above ground use applications. So that's one thing. With regards to decking, we do make decking. We do make treated pine decking as a product category within Timberlink. The other product category we do make as well is actually we take our residues from Bell Bay, which is our Launceston sawmill. We take those fiber residues that we get from cutting the logs, so sawdust and chip and things like that, and we actually turn that into a wood plastic composite decking range.
Oh, yeah.
And we just released that into the market last month or thereabouts. So it's only been in the market for a very short period of time. We started in Tasmania, and we'll bring it across to the mainland. But that's another project that we've been able to take some residues, which would otherwise go into pulp and paper and things like that, and actually value add and add that into a high value commodity item that we can then sell into the construction sector. So I'd encourage you to look at the wood plastic composite range, which is Everdeck, as well as our treated decking products as well.
Okay.
But we don't do any hardwood decking.
My second question was that can curves be made using the GLT for like exposed columns or beams and that?
Yeah, so glue-laminated timber in general can be curved. So they make a form, whether they use a steel form, like with an adjustable steel form, or they make a timber form and actually laminate each layer into that form and then let it dry, and then you end up with that profile. That's something that we don't offer. There are manufacturers in Australia that do curved glue-lam. I can think of 3 off the top of my head. Big Beam, Masswood, and Hine. They all do curved glue-lam, but that's not something that Timberlink do.
There was just one missing step in there. Who does the design and specification of all the connection details? So like all your screws from CLT to CLT connections or CLT to GL, is that a third-party engineer, or is that part of your design process as well?
Yeah, so that's the responsibility of the structural engineer. So the engineer on record will need to design and specify all the connections. There's a number of suppliers and manufacturers in Australia now which actually distribute third-party connections for all our project. Well, not for all, but we have access to connection suppliers. So during the shop drawing process, we will actually do the material takeoff of those connections, but the actual ultimately the specification of them is up to the engineer. So they'll actually design it and say they need this size screw at this many centers. We'll do a bill of materials and we'll actually procure those and get them delivered to the site ahead of time. But we won't do any engineering design and we won't do certification. That's all up to the engineer of record to do that.
And the second question is, as a designer, if say in the residential industry, probably is more pertinent, do you have any sort of rough price guidance where we can go, as you know, design cost analysis with the client, if they were to choose CLT as an option, what's the rough dollar per square meter of a wall, 90mm wall panel and say 140mm roof panel, and 140mm floor panel, that you can sort of go, look, if we swap out light timber framing and go with this, what would the cost analysis be?
Yep, we can comfortably do that. Yep, not a problem at all. So we got the way that our pricing works is that we price panels on a square meter rate. And then there's occasionally, depending on the complexity of the project, there's extra overs for complicated CNC work or manual handling of very small components and things like that. But our panel rate is consistent, whether that be a commercial job or a residential job, but it doesn't change. And so what we actually sell the actual entire billet. So we'll make a big billet that's 16 meters long, cut out all the components inside of it, but the actual customer will pay for the entire billet. So they'll pay for the billet, they'll pay for the waste, they'll pay for the panels, and they'll pay for any additional CNCing work that's required. So, so when we if we do give a rate or a price, you need to factor in, okay, there may be 15% material waste on top of that, which needs to go, or 20% depending on how complicated it is. But typically wastage falls around the 10 to 15% mark. Yep.
Okay.
So if there's a concept, so Luca and myself, we pull together concepts all the time for designers. And we can say, okay, that's going to be about 140. That'll be about 200. So yeah, we can work through that.
So the process would be get a design in place and then send it to your sales department, get a rough square meter rate or a quote, and then it can be financially analyzed with the client after that.
Correct, 100%. Yeah, absolutely. Yeah.
Cool. Thank you very much.
Yeah. So, but it saves you guys going racing off and doing an entire design, and before you work out it's going to be feasible or not. Do enough to know sort of what your supporting elements are going to be, what your spans are going to be, and then we can come up with a fairly indicative price from there, and you can work out if it's got legs or not.
I've got a question that might test your engineering background.
I think we're running out of time.
I'm just wondering if, obviously there's no like definite answer, but I'm wondering if there's like a rule of thumb to compare thickness of cross-laminated timber for a similar use where you would otherwise use a concrete precast panel. For example, like if you're doing a floor structure, you know, in concrete, you might have like a 200 mil structure, whereas with cross-laminated timber, what is there like a rule of thumb of how thick that might be?
About span on 30 is about where you kind of get to. Span on 25 to span on 30 is indicative on where you'll end up with. So if you have a 6 meter span, for example, your floor plate in a commercial setting is going to be around about 200 thick, thereabouts, and then down to 4.5 meters, you're probably around about the 150 mark. So around about that span on 30. So span by 30 will give you an indicative thickness. Walls is a bit of a different story because it all depends on loads. But in our technical guides, there's some preliminary pre-analysis span tables in those guides. So you can just go have a quick look up. Okay, that's my span, that's my load. It's a commercial setting. Okay, bang. Okay, that's my floor level. So I'd encourage you to go and just download those. They're pretty self-explanatory. That's all there. And same for walls. It has walls with particular heights because your height of your wall has a fair bit to do with it. But there's indicative span tables for walls as well.
Yeah, so that would be the thickness to carry your loads, and then you could add the extra thickness for your char layer.
Yeah, when the bigger you build though, like if you have a really long spanning commercial floor, as I said, your floor is going to be around 200 millimeters in thickness to start off with. So your performance criteria at the end of a fire is very different to your performance criteria in service. So effectively, the criteria, the design criteria is relaxed at the end of a fire. It basically just has to be standing and stable.
Yep.
So you can lose a lot of that floor, like in a 90mm fire, you'll probably lose 75 millimeters, which means you've still got 150 millimeters worth of floor left in a commercial setting, which will be perfectly capable of supporting your actual fire design loads. So you typically don't have to add any additional fiber in the fire case in commercial settings. Small spans are a little bit different. They can be a little bit different, but those longer spans are typically governed by vibration performance and just structural performance over that long spans. And typically fire case doesn't govern.
Yeah, okay, that's
So
really
it's a bit hard to give just a one size fits all answer.
As per manufacturer's guides. Okay, Christina.
First
As per
specification.
structural engineers analysis is what I'd say.
Sorry, my apologies. Jeremy, you're probably running factory tours, so all of us interested.
Certainly do. Yep.
Well,
We're actually got we're doing factory tours today and tomorrow. Actually, got a couple of customers coming down from Sydney to do that. We've also got about 20 or 30 engineers going through on Friday. So if you're asking me, can you have a tour? Absolutely, you can. No question about that at all. If you can get across to Mount Gambier, somebody from Melbourne or Tarpena will meet you. We have to organise it well ahead of time, but we're more than happy to accommodate tours and things like that. If you've got the time and there's sufficient interest, what I really encourage people to do is take a whole day. We go to the nursery first, and then we can go to the forest, and then we can go to the sawmill, and then we can go to NeXTimber. That takes a whole day, but it's pretty insightful, and people can see the whole supply chain. And we've got the luxury we can actually do it in that region. So
awesome, thank you.
Yeah, thank you so much, Jeremy. I really appreciate it.
not a problem. Thanks for having me.
And hopefully our audience will be in touch with their future projects, and we'll be seeing a lot of CLT and GLT construction sites in the near future.
Fingers crossed.
Absolutely.
Excellent.
All right.